Okay, today we're going to review for Exam 9 in Chapter 18 on electrochemistry. And in your schedule, you'll see that this day is a buffer day, which I had reserved for overflow from the lecture. But since the lecture's completed already, I'm going to start the review today and probably finish today, which means next Thursday. No, next Thursday, I'll make it a tutorial day and I'll just zoom in from my office. That way, next Tuesday will be the exam on this material. And since most of the class traditionally has been, the exam has been taken in Brightspace, what I may do next Tuesday is just start the review for the final. That way, it'll give us that Tuesday and the following Thursday to review for the final exam. And then when the final exam comes up the following week, we'll have that much more opportunity to discuss problems that may arise. Okay, so today I've got some of the items here as questions in the review document highlighted, so I won't miss them. And we're going to start off with number 1. Consider the following a reaction. We have barium and chlorine yields barium chloride, right? So which of the following statements is true? Well, since we're in electrochemistry, we know that we're going to have to watch the movement of electrons. So let's just start with that, right? And let's go to our oxidation states, right? These are elements, so they're going to be zeros. And we know from, actually from nomenclature, we know that barium, since it's an alkaline earth, is going to be at +2. That's also its oxidation state, and halogens will be a -1. Okay. So, what happened to the electrons? Well, barium went from a 0 to a +2, so it had to lose 2 electrons, right? So we have a loss of 2 electrons per barium times 1 equals 2 electrons total. Chlorine went from a 0 to a -1. So that means it had to gain 1 electron per chlorine times 2 chlorines equals 2 electrons. Okay. Now we should be able to discern which one's which. Let's put in our proper terms. Loss of electrons. Oil rig. Oxidation is loss. So this barium was oxidized. This chlorine was reduced. Okay. So let's see our choices. The barium atom is losing electrons. Yes. Therefore, it's oxidized. That is true. A is true. How about the others? Well, since E says none of these, then we can assume, since we found the correct one, that A is the answer. If we look at the others, we'll find that there's something wrong with each one of them. Chlorine atom is gaining electrons. Yeah, that's true, but it's not oxidized. Right? So B is false. C, the barium atom is gaining electrons. Well, that's false on its face. And then our last possibility is D, the chlorine atom is losing electrons. No, it's gaining electrons. Okay, so that's the only possibility, A. Well, let's look at number 2. In this reaction, calcium and oxygen makes calcium oxide. All right, well, two of these. Okay. The calcium is what? Well, the calcium went from 0 to 2 plus, right? Since that's the question, that's as far as we need to go. Calcium lost 2 electrons. It's oxidized, right? Calcium is oxidized. So we found our answer. How about 3? In the reaction strontium plus fluorine, yields strontium fluoride. Well, what about the fluorine? Well, fluorine starts at 0 and goes to -1. So this is reduced because it gained an electron. And the fluorine is reduced. Number 4. Scroll a little bit. The oxidation state of sulfur in potassium sulfite. First of all, is that written correctly? Well, yeah. Potassium's +1. Oxygen's -2. Well, actually, the whole sulfite is a -2. So the -2 for this group, the polyatomic ion, balances the 2 pluses from that. But now we're going for what's the oxidation state of sulfur? So 3 times the -2 is a -6. And 2 pluses together make a -4. So that means this one sulfur has to balance that -4 with a +4. Okay. Number 5. Oxidation state of chlorine in lithium chloride. Well, we do have a rule. We don't have to assume that chlorine is a -1, even though it is. We do have a rule for lithium. Lithium is an alkali metal, so it is a +1. That means chlorine has to be a -1. No other option. How about number 6? The oxidation state of carbon in CO2. Okay, now we're into covalent compounds. So we're not looking at charges anymore. We have to go back to our rules. And in this case, oxygen is a -2, which is a -4 total. That means carbon must be a +4 to balance. How about the oxidation state of sulfur and sulfate? The sulfate ion. Remember, the oxidation states, the total of the oxidation states must equal the charge on the polyatomic ion. We know that oxygen's a -2 times 4 is a -8, but we need to hold 2 of those negatives out for the charge. That means that sulfur only has to balance this -6 with a +6. Let's see, let's go down to number 9. And just because I'm skipping some of them doesn't mean that they're not important. It's just that we have a limited amount of time. And once you've got the technique mastered, You should be able to determine the oxidation state for any element in any compound or polyatomic ion. I'm just picking these out because they're unique in some respect. Okay, H2CO3, what is that? Well, if it's aqueous, we know that's an acid, right? It's carbonic acid. But the question, that's not the question. The question is, what's the oxidation state of carbon, right? So we have a +1, that's the rule. We have a -2, that's the rule. So we have 2 times that one is a +2, and 3 times this one is a -6. We have a -4 there. That means this carbon must be a +4. The oxidation state, trick question. What's the oxidation state of rubidium in any compound? Well, if it's an element, it's 0. But if it's in a compound, rubidium, you look at your periodic table, rubidium is an alkali metal. And the rule says it's +1. That's it. Remember, oxidation states are used as bookkeeping schemes for tracking electron movement, right? Sometimes we can say, yeah, it relates to the charge, right? But not always. It doesn't have to. About 12. The oxidation state of oxygen in O2. All right, now we do have an elemental oxygen in its most stable form at 1 atmosphere pressure and room temperature. That oxygen has to be 0 oxidation state. All right. And we'll skip a couple more and go down to 15. The oxidation state of phosphorus in magnesium phosphate. Okay. 2 approaches, right? You can take the entire molecule together, and that'll work. Or you can take out this polyatomic right here that we know to be PO4 3-, right? So if oxygen is -2, that's a -8 total. We need to hold out 3 negatives for that charge. That means that phosphorus is +5. Or you can do the entire molecule. We'll do it that way too. Do the entire molecule. Then we know that this -2 is -8 times 2, -16. Okay? Then this one is magnesium, which is a 2+. It's an alkaline earth. A 2+ is a +6. Right? So altogether, this is a -10. Then we have 2 phosphoruses, right? 2 phosphoruses that must balance that -10 with a +10, which each one of them must be a +5. Right? So we get to the same answer by different routes. All right, number 17. Dichromate ion. What's the oxidation state of chromium in dichromate? We did this one during the lecture, but we're going to do it again. Right. -2 times 7 is -14. We hold 2 of them out for that 2 minus. -12 then must be balanced by this 2 chromiums, so each one is a +6. All right, we skip a few. Get down to 28. In reacting, metal atoms characteristically do what? Well, metal atoms, when they react, let's say that's our metal. When they react, they usually lose electrons. Now, this is if it loses one electron, it could lose more and give you a different charge, but this illustrates the fact that metals tend to lose electrons, which they tend to be oxidized. All right. Okay, so let's see what we got here. A says become anions. No, they become cations. Lose electrons? Yes. B is true. Decrease in oxidation state? No, they increase. They go from a 0 to a +1. That's an increase in oxidation state. They form covalent bonds. Typically, metals do not form covalent bonds. They form ionic bonds. Two of the above? No. We only had one that was true. $29. All right. Which statement is true of the following reaction? Well, let's see. I'm not sure why I have that one in red down there. Let's answer the question first. In this following reaction, we have 2 potassium and copper 2 chloride yields 2 potassium chloride plus copper. Okay. Which is true of this one? Well, let's analyze it. Oxidation state there and there. That's easy. Chlorine, in this case, we have to assume that the halogen is a -1 because we don't have a rule for copper, right? So that means -2 here, that's +2 there. This one is a +1, that's a -1. So now we can track our electrons. Potassium goes from 0 to a +1, right? That's a loss, 1 electron for each potassium times 2 potassiums equals 2 electrons. Then the chlorine doesn't change. The copper does change. It goes from a +2 to a 0. So how did it get there? Well, it gained 2 electrons for each copper times 1 copper equals 2 electrons. Okay. So now let's see, what are our choices? Copper is reduced. Copper gains electrons. Yes, copper is reduced. So A is true. Chlorine is reduced. No, chlorine doesn't change. How about C? Potassium is reduced. No, you can't have one reduced and the other one reduced also. This one must be oxidized. Right? So that one's false. D, copper is oxidized. Well, copper can't be reduced and oxidized both, not in this situation. Right? We have a situation where we could say that, but not in this case. And then the last one, chlorine is oxidized. No, chlorine doesn't change. Right? So that first one is the only one that's true. Now, let's see. Why did I put that? Well, let's look at that one in red. I put that in there for a reason, but I'm just not sure what it is. Let's analyze it. Let's see. We have copper 1 oxide and sulfuric acid, and then yields copper and copper sulfate and water. Okay. Now, is that balanced? Let's see. We have 2 coppers here. We have 1 there and 1 there. we have this oxygen plus 2 hydrogens makes water, and we have 1 sulfate right there. So that's balanced. All right. What happened? Well, one of these coppers went here. 0. This copper is a +1. Okay. This hydrogen is a +1. The sulfate didn't change, so we don't have to deal with that one. Hold on a second. Because this is a 2+. Yeah, okay, that works. Nothing happened to the hydrogens, the sulfurs, the oxygens. Everything happened to the coppers. So this 1 copper here went to that one by gaining 1 electron. And the other copper went to here. And it lost 1 electron. Okay? This is an example of a disproportionation reaction. So it wasn't that 1 copper was oxidized and reduced. It is that 1 copper in this compound was oxidized and the other copper was reduced. All right. It was 29. How about 30? In which of the following does nitrogen have an oxidation state of +4? All right. B, C, D, and E. So our compounds are nitric acid, nitrogen dioxide, dinitrogen monoxide, ammonium chloride, and sodium nitrite. Okay, let's just do the oxidation states. That's the simplest way to go. All right, -2 and +1. Let's see, we'll stretch it out here. So we've got this +1 here, and we've got -6 here. Right? 1 plus and -6 is -5. So that nitrogen must be a +5. That's not it. This is a -2, which is -4. This is a +4. There you go. Got your answer. Let's go ahead and do the others just for fun. -2, that means each one of these has to be a +1. And let's see, a -1, this is a +1. So that's a +4. And the -1 is a +3. This is a -3. And let's see, nitrogen. Okay, we can do this one as this is an NO2 minus. So it's a -2 times 2 is a -4. We need 1 of those. So this is a +3. So we have different oxidation states for these nitrogens. Lots of different oxidation states. And if you look at your periodic table, some periodic tables give you in one corner of the block with the elements. So we're looking at nitrogen, and it'll give you what looks like charges. Right? The top one could be a charge. So for nitrogen, the top one will be a -3. And it'll go through a -2, a -1, 0, +1, +2, +3, +4. Those are all possible oxidation states, not charges. All right, that was 30. And next, 34. Answer the question that refers to the following reaction. Which species is the reducing agent? So we have titanium 4 chloride. Let me make a point. When you have an ionic compound with a halogen, you can assume that the halogen is going to be a -1. Right? Because halogens in ionic compounds are always -1. If you have a halogen in a covalent compound, then you've got to make some assumptions. But as long as it's combined with a metal, it's always -1. Right? So that makes this a +4. All right, then let's complete the reaction. Oxygen, right, with the 0 oxidation state. And then we get titanium 4 oxide, right, plus 2 chlorines. Okay. Okay. Well, chlorine went from -1 to 0. This is a -2, so that's a +4. So the titanium didn't change. The chlorine changed, yes. Chlorine went from -1 to 0. So it had to lose electrons. Loss of 1 electron per chlorine times 4 equals 4 electrons. That means with a loss, this is oxidized, which means what? It's the reducing agent. Oxygen went from 0 to -2, which is, it was gain, right? 2 electrons per oxygen times 2 equals 4 electrons. Oxygen was reduced. So it is the oxidizing agent. Okay. Question is, which one is the reducing agent? Well, the reducing agent would be titanium 4 chloride, right? That's the only option that you're given in this multiple choice. If it had said chloride ions, right, chloride ions, then I would have picked that one because that's the actual species that's being oxidized, makes it the reducing agent. But since titanium chloride is given, that's your answer. 38. Okay. And the reaction, phosphorus plus 10 chlorines is 4 phosphorus pentachloride. Phosphorus is, okay, so we have P4 plus 10 chlorines yields 4 phosphorus pentachloride. All right, that's a 0 oxidation, 0 oxidation. In this case, we have to assume, since this is a covalent compound, right? 2 nonmetals, covalent. We have to assume that the halogen is a -1. We don't have any other choice, otherwise we're stuck. So that's a +5. So let's see, what's the question? Phosphorus is what? What happens to the phosphorus? The phosphorus goes from a 0 to a +5. So there's a loss of 5 electrons per phosphorus times 4 equals 20 electrons. This is oxidized. Phosphorus is oxidized. 39. In the reaction, oh, I should have left it up there. Okay, what happens to chlorine? All right, I can do it again. P4 chlorine, which is 10, yields 4. Okay. Okay, what happens to chlorine? Well, chlorine starts at 0 and ends up at -1. So chlorine it gains 1 electron per chlorine times 20 equals 20 electrons. So it is reduced. Okay. Let's be sure I don't need it again. 44. In the reaction, magnesium plus sulfuric acid yields magnesium sulfate plus hydrogen. Which element, if any, is oxidized? Well, let's see. Magnesium plus sulfuric acid yields magnesium sulfate plus hydrogen gas. Is that balanced? 1 magnesium, 1 sulfate, 2 hydrogens. Yeah, that's balanced. Which is oxidized? Well, that's a 0 state, 0 oxidation state. Sulfate didn't change. So we know that sulfur is the same, oxygen's the same. Hydrogen starts off at +1. Magnesium ends up at a 2+. Okay? So which is oxidized? Well, first of all, there's a real neat little trick to determining whether a reaction is redox. We may have covered this before when we studied reaction types. But if you've got an element on one side and it's a compound on the other, there has been oxidation reduction. All right? Or if it's in a compound on one side and it ends up as an element on the other side, there has been oxidation or reduction. So we know this is a redox reaction. The question is, which was oxidized? Well, which one lost electrons? We had to go from 0 to 2+ for magnesium. That's a loss of 2 electrons for each magnesium, right? So magnesium was oxidized. Let's see, let's go down to 48. In the following reaction, which species is the reducing agent? So we have 3 coppers plus a hydrogen ion, actually 6 of them, sorry, plus 2 nitric acid yields 3 copper 2+, 2 NOs, and 4 waters. All right. So we're looking for the reducing agent. Which one was oxidized? That's a reducing agent. Well, let's see, that's 0, that's +1. These change, right? So this is a +1, -2, -6, and a +1 is -5, so that's a +5. That's a 2 plus. This is a -2 and a +1. -2, +2. Okay, so which one was oxidized? Well, copper went from 0 to 2 plus. Copper was oxidized. It lost 2 electrons per copper times 3 equals 6 electrons lost. So copper was oxidized, making it the reducing agent. And let's see, we're going to need that. We're going to need that one again. I don't think so. Okay, so I can erase this one. We'll go to 49 next. All right, in the following reaction, 49, answer the following question that refers to the unbalanced reaction shown below in acidic conditions. Determine the coefficient for the iodide ion. So we've got to balance this one by the method of half reactions in acidic solution. All right, so we have chromate, dichromate ion. And then we're given iodide, yields, chromium 3 plus, and diiodide. Okay, so we've got to decide which one's the reducing step and which one's the oxidizing step. All right, -1, 0, 3 plus. This one has -2 times 7 is -14. Hold 2 out, -12. That makes this one +6. Okay, so which one was reduced? Well, chromium went from +6 to +3. It had to gain 3 negatives, 3 electrons in the process. So this is the reduction step. Chromium, dichromate ion, and I'm going to put that up there, yields Cr3 plus. That means the iodine must have lost electrons. It went from -1 to 0. There we go. Okay, so balance the non-hydrogen, non-oxygens first. We need 2 chromiums over here. Okay, and then iodides, we need 2 there. Now balance the oxygens. We have 7 oxygens on this side. We need 7 on this side. But now we've added 14 hydrogens. So we need 14 protons. Now we can do electrons. We went from +6 to 3 plus by what? Gaining 3 electrons for each chromium, but we have 2 chromiums. So we actually gain 6 electrons. All right. In this one, we lost 1 electron per iodine, but there are 2 iodines. So we've got 2 electrons lost. Okay, now we need to reconcile. How do we get these reconciled? Just multiply this one by 3. Right, so we get 6 here, 6 there, 3 there. Those cancel. And let's see. The question was iodide ion. What is the coefficient for the iodide ion? Now, Are we going to cancel iodines in the process? Right? We don't have iodine on both sides. So this is the term that's going into the final equation, 6. So there's your answer. Instead of bringing it all down, just look for the answer. The answer says, what's the coefficient in front of the iodide ion? And this is not going to change when you bring it down, add them together. So there's your answer. 6 goes in front of the iodine. Now, if it had said something like, what's the coefficient in front of the water molecule? Well, there's no water molecule there. Yeah, but there will be, right? There will be, and it's right here. 7 waters. So that would be the coefficient in front of water. You know, in case I get sneaky and want to change it up a little bit. Let's see. Okay, 50 uses the same equation and wants to know the chromium 3 plus. Chromium 3 plus would be 2. Right? How about the next one? Determine the coefficient of water. Well, there it is. If I had said water, it would have been 7. Okay, now we can go to a new one, 52. The point I was trying to make was, don't just memorize the answers. You need to understand how to do the procedure, because it's very likely that I won't give you the same questions. They might look alike, but they won't be the same and they won't have the same answers. So you got to know how to run the procedure. 52. For the reaction of sodium bromide with chlorine gas to form sodium chloride and bromine, the appropriate half reactions are, all right? This is a word problem where you've got to be able to write the compounds and the elements and the ions, whatever. Okay, sodium bromide with chlorine gas. Sodium bromide, chlorine gas is diatomic. Yields what? Sodium chloride and bromine. Sodium chloride and bromine. There we go. Now, if you don't know how to do that, you're stuck. You can't answer the question. All right. This is 0 oxidation, 0, +1, -1, -1, +1. Okay, let's see, oxidation step first. Answers say oxidation step first, reduction step second. So who's oxidized? Well, who lost electrons? Bromine went from -1 to 0. Bromine lost electrons. But, well, let's do it like this. Sodium bromide, and then bromine. Okay, so if it lost electrons, how many did it lose? Well, you need 2 there, right? And it lost those 2 electrons. Then chlorine went to sodium chloride, right? -1. So 2 chlorines, and it gained 2 electrons because there are 2 chlorines. All right. Now, we want to, what is the spectators, right? If we throw out the spectators, that's the sodiums. Sodiums are the same on both sides. They didn't change. So we can substitute here 2 bromines, -1. And here we can throw these out, and we have 2 chloride ions. right? That's all that's happened here. We've just removed the spectators. Now what do we got? Well, let's see. We've got 2 electrons for each one. That's fine. So we've got 2 Br minus and Br2. 2 Br minus and Br2 is 2 minus. B covers that one fairly well. Does the other part satisfy? 2 chlorines, 2 electrons, 2 Cl. So B is a good answer. And I just showed you why the answer doesn't have sodium in it anywhere, because sodium is a spectator. Right? We're only interested in the ones who undergo oxidation or reduction. Okay, how about 56? All right, when the following reaction is balanced in acidic solution, what is the coefficient of water? All right, so we have zinc and nitrate ion. It leads to Zn2 plus and ammonium. Okay. So we've left out spectators here also, right? There should be a counter ion, cation here for this one. Could have been sodium, right? And then there was a counter ion here, right? Could have been chloride, but we left them out because they're spectators. All right, so let's balance this one in acidic solution. Let's see, we'll do oxidation first and then reduction. Okay, 0. And this night, that's a -2, so -6, -5, because we hold one out. This is a +5. And then 2 plus, and this is a +4, but we hold one of those out for that, so it's +3. This is a -3. All right. So zinc went from 0 to 2 plus. It lost electrons. So we got zinc going to Zn2 plus. Okay. And that means nitrogen gained electrons. It went from NO3 minus the +5 here, and it went to ammonia with a -3. Okay. So now, one zinc, no coefficients needed. One nitrogen. Okay, we're good there. So now let's balance the oxygens. There are no oxygens here, so we skip. Go down to this one. That's 3 oxygens. We need 3 oxygens on that side. Okay. Now, how many hydrogens do we have? We've got 6 plus 4 is 10. We have 10 hydrogens that need to go on this side. Okay. Now we can balance electrons. Oxidation step. That means electrons are on this side. Okay. A reduction. Electrons are on this side. How many are there? We went from +5 to -3. How do you get there? Well, from +5 to 0 is 5 added electrons. And then from 0 to -3 is 3 more. That's 8 electrons. So we added 8 electrons on this side. All right. Now, how do we get balanced? just multiply this one times 4. Like that. There's 4 there, and 8 there. So we're balanced. Now the question was, what's the coefficient in front of water? Well, water's only on one side, so it's not going to cancel. That means the coefficient is right here. 3. 3 is the coefficient of water. Let's see, we need to keep that one for any reason? I don't think so. Okay, let's go back. 56. And we can move down to 58. Which of the following is true for a galvanic cell based on the following reaction? Well, let's see. We know that zinc metal is going to be 0 and copper metal is going to be 0, and the ions already have their values given, so we don't have to put it on the board. We know that zinc is going to lose 2 electrons. Zinc is oxidized, right? So where is the site of oxidation? The anode. So zinc serves as the anode. B. B is true. Right? B is true. A is not true. Zinc is being reduced? No, zinc is being oxidized. It serves as the anode. It's being oxidized. So B is true. C, the copper 2 plus is being reduced. Yeah. Add 2 negatives to 2 plus and you get copper metal. 0 oxidation state. So C is also true. Copper 2 plus is being reduced. Right? The copper does not serve as the anode. The copper serves as the cathode. The cathode is the site of reduction. So 2 of them are true. These 2 are true. E is your answer. $60. Right. In a car battery, which of the following is the electrolyte? Right? Pure memory. Go back to visualize the car battery. What do you have in a car battery? You have plates. I'm only going to draw 2 of them. One of them is lead. The other one is lead 4 oxide. Right? What's the electrolyte? The electrolyte is sulfuric acid. Okay, that's it. That's the answer. We're still talking about the lead battery. 61. Okay. PbO2 is found at the. So what is happening to PbO2? Well, you have to know that at both electrodes, the lead electrode, we're producing PbSO4. So that's a +4. It's going from 0 to +4. So if it's going from 0 to +4, that would be the site of oxidation, which is the anode. And this 2 plus lead is going to Pb4SO4. It's being, wait a minute, 0 to +4. No, excuse me. +2. That's +2. This is +2. This is +4. All right. Okay, so let's start again. 0 to +2 is the anode, oxidation. +4 to +2 is the cathode, site of reduction. There we go. All right, so back to the question. PbO2 is found at the cathode. A, cathode. '63. When a metal corrodes, what's happening chemically? Well, the metal is being oxidized, right? It's losing an electron, at least one electron, usually more than one, but that's our example. The metal is losing electrons. It's oxidized. Oxidized. It's losing electrons. A is a good answer. Now, not in all cases, but in many cases, the metal is combining with oxygen. You can also get oxidation if it's combining with sulfur. But that happens in the atmosphere as well. We have some sulfur in the atmosphere and it will combine with metals. But most often it's oxygen. Okay, 66. Let's see, balance following redox reaction in acidic solution. What's the coefficient of the water? All right, methanol, CH3OH. Let's see, aqueous. And then we're throwing out 07, 2 minus, that's aqueous. And then CH2O is formaldehyde. And Cr3 plus. Yes. So this is all occurring in aqueous solution. Which means what? If we try to make a battery out of it, we have to have inert electrodes. All right, but the question is, what's the coefficient of water? All right. Oxidation step, reduction step. So let's see. This was +6, I believe. Minus 14. Yeah, +6. There's +3. That's a -2. That's a +2. Is that right? Yeah, 2 times +1, -2. All right, so that's 0. That's 0. That's odd. Carbon to have a 0, but it's in a compound. All right, this one has +1, -2, +1, so that's +3, +1, -2. All right, so that's a +2. This is a -2. Yeah. Okay. So what's happening here? Well, let's see. -2 to 0 means that carbon was oxidized. So we put this one here, -2. Nothing happens to the oxygens or the hydrogens, so we don't include those. At least not for our movement of electrons. All right. That means reduction must have been chromium +6 to +3. Yeah. And then chromium. There we go. Okay. Carbon's good. Oxygen, hydrogen, we save those. 2 chromiums. There we go. All right, now let's do oxygens. We got 1 oxygen here, one oxygen there. We got 4 hydrogens here and only 2 here. So we need 2 hydrogens on that side. I have 2 chromiums, 7 oxygens on this side. So we need 7 waters on this side and 14 hydrogens on that side. Now, electrons. We had to lose 2 electrons for each carbon. Here we go. And we gained what? 3 electrons for each chromium, but there are 2 chromiums. So that's plus 6 electrons. Okay? So now this one needs to be multiplied by 3 to give you 6 electrons. All right, so we put a 3 here. We put 3 here, 6 here, and 6 there. Okay. Let's bring this one down because I'm going to look at 67 also. So we had 3 methanol. We had 1 dichromate ion. We had, well, electrons cancel. We had 14 hydrogens on this side. So that's 1, 2, 3. We're good. On this side, we have 3 formaldehyde. We had 2 chromium 3 plus. We had 7 waters. And we had 6 hydrogens. Okay, now we can cancel terms. No waters on this side, but there are hydrogens over here. Those 6 go out, and we're left with 8. Okay, and we can't reduce that any further. So, what's the coefficient of water? 7. All right. And I don't have it marked, but let's move down to 67 and see what that one is. So this answered 66 was that one right there. 67 asks what? What's the coefficient of hydrogen ions? Well, let's see. Hydrogen ions here, it's 8. Right? Okay. Let's see. We're going to have one in basic solution. We're not finished yet, so probably will eventually. Let's see, number 70. So we've got the, let's see, what would that be called? That's a polyatomic. I don't know what that's called. Tetrachloro gold 3. Copper yields gold and chloride and copper 2 plus. Okay. How many electrons are transferred? All right. We do oxidation states first. Okay. Those are good. Those are good. What's this one? Let's see. We have to assume that this is -1. -4 total, but we have to hold 1 out. So that's a +3. All right. Chlorine didn't change. Copper changed. Gold changed. Right? So We might be able to solve this with tie lines because there are no oxygens and hydrogens here. We don't have to work with water and protons. So let's use tie lines and see if we can figure this one out. Right? That was a gain of 3 electrons for each gold. Times 1 equals 3 electrons. Okay? And the copper lost, right? Loss of 2 electrons per copper equals 2 electrons. Okay, we got to balance the electrons, right? We got 3 here and 2 there. The easiest way to fix this is cross multiply. That 2 needs to go here. 2 and 2. That gives you 6 electrons. All right. And this 3 needs to go here. 3 and 3 times 3 equals 6 electrons. So the number of electrons transferred is 6. Okay. Now we didn't, I don't think we completely balanced the equation because now we have 8 chlorines. Okay. And we have 3 coppers and 2. Okay, it's balanced now. We're good. Let's see. We need that again later. I don't think so. We can go to 71 now. All right. How many electrons are transferred in the reaction? 10 plus 2 hydrochlorics yields 10 2 chloride plus hydrogen gas. All right. 10 plus 2 HCl yields SnCl2 plus H2. How many electrons are transferred? Is that balanced? 110, 2 chlorines, and 2 hydrogens. Yep, that's balanced. -1 plus 1, -1, and plus 2. So hydrogen had to gain 1 electron per hydrogen times 2 equals 2 electrons. And 10 had a loss of 2 electrons, right? Times 1 equals 2 electrons. That's it. We found our answer. 2 electrons are transferred in this process. Oh, yeah, 71. 2 electrons. Had to do a double take. All right, there's a problem with this. Well, this is a key. Hopefully I don't have that same problem. Right. Because this needs to be E. Not enough information should be E down here. $75. Right. Let's see. In an acid dry cell battery for which the reaction is, what is oxidized? All right, so this has got water. I don't see any hydrogen ions in there. Let's see if it's balanced first. We got zinc and 2 ammonium chloride. Well, we do have some hydrogens. They're just not separated. 2MnO2. Two ammonias plus Mn 2O3, and then water. Okay. All right. So that's 0. Let's see. This nitrogen is going to be the same as that nitrogen. I'll prove it to you. +1, -3. All right. -1 + 1, that's +4, and -1 is +3, -3. So nitrogen is not oxidized or reduced. This one's -2, so that's +4. This is -1, so that's +2. All right. So zinc did do something. Manganese, this is -2, -6. So this is a +3, right? 3 × 2 - 2 × 3 +. Okay. And the hydrogen, the oxygens didn't change. Hydrogens didn't change. So, go back to the question. What atom is reduced? If we're going from 0 zinc to 2+, that's oxidized. Right? If we're going from nitrogens, no. Manganese is +4 to +3. It gained 1 electron. So this is reduced. Manganese is reduced. Well, in the form of MnO2. Let's see. Oh, wait a minute. What's oxidized? Oh, we found it. Sorry. Zinc is oxidized. MnO2 carries the species that's reduced. But the answer is A. Zinc is reduced. Oxidized. Zinc is oxidized. Oh, and this one uses the same reaction to find out which one was reduced. Well, manganese is reduced. Here. That's reduced. Let's see. I'll skip a few. And let's try number 83. Okay, when the equation for the following reaction in basic solution is balanced, what's the sum of the coefficients? All right, so we're going to balance this one in basic solution. MnO2 plus HO2 minus. That's the peroxide ion, MnO4. Okay. Yeah, this is the peroxide ion. It's like hydrogen peroxide would be like that. And if we lose one of those, then we're left with a net negative charge, because this one goes away as a plus ion. So that's what we're looking at right there. That's the peroxide ion, hydrogen peroxide ion. Okay, so we're going to balance this in basic solution. Oxidation, reduction. Okay, manganese. This is -2 times -4. This is a +4. And this is -2 times -8. This is a +8. Oh, that's negatives. Sorry. My mistake. Let's start over again. So now we have -2 times that's -8. Pull one of them out. That minus is -7. So this is a +7. There we go. That looks better. Okay. Which is oxidized? Well, we go from +4 to +7. This is definitely oxidized. Plus 7. The only thing left for reduction is HO2 minus. We just don't know what it is yet. Well, I have an idea, but it's not given. So we got one manganese, good. We have only hydrogen oxygen here, so we're going to start. Well, let's get this one fixed. We got 2 oxygens and 4, so we need 2 H2Os, and that means plus 4 hydrogens. On this one, we have 2 oxygens on this side. We need 2 on that side, which means we already got 1 hydrogen, so we only need 3. Right, so that should be balanced. 2 oxygens, 1, 2, 3, 4 hydrogens. All right, now we can assess this oxygen is a -2. No, it isn't. It's a -1. Why do I know that? Because this is a peroxide. And oxygen in peroxide is a -1. So it went from a -1 to a -2. That means it was reduced. Okay, well, while we're here, if it went from a -1 to a -2, that's 1 electron for each oxygen, but there are 2 oxygens. So we had to reduce it with 2 electrons. Okay? Now back up here. +4 to +7. That means it lost how many? It lost 3 electrons for each manganese. Right? Yep. Okay. Now let's reconcile the electrons. 2 and 3, we cross multiply. We bring a 3 down here and a 2 up there. So now we have a 2 here, 4 there, 2 here, 8 there, 6 there. Then we have a 9 here. We have a 3 there. We have a 6 here, 6 here. Okay. Now let's bring it down just to be complete. We have 2 MnO2. 2 MnO2. We have +3 HO2 minus. We have 4 waters, right? And we have 9 hydrogens. Okay, and the electrons cancel. Okay, on this side, we have 2 MnO4 minus. We have 6 waters. And we have 8 hydrogens. Okay? Let's see. Did I bring everything down? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. Now let's cancel common terms. There are 8 hydrogens on this side. That leaves us 1 hydrogen here. There are 4 waters on this side. And that leaves us 2 waters there. Okay? Now let's neutralize this hydrogen. +1 hydroxyl, +1 hydroxyl. That makes 1 water and 2 waters over here. So this goes out, and now we're down to 1 water. Okay? So the question was, what's the sum of the coefficients? Well, let's see, it's 2 plus 3. That's it. Plus 2 plus 1 plus 1. So that's 2, 4, 6, 9. Coefficient, sum of the coefficients is 9. All right. That was a toughie, I'll admit. Okay, 85. All the more reason for being very methodical about your problem solutions. Don't get in a big hurry. Don't think you can look at the problem and then just instantly, poof, there's the answer. Doesn't work that way. 85. The following reaction occurs in basic solution. All right. And let's see, silver and copper. All right. When the equation is balanced, the sum of the coefficients is. Now, do we need to be concerned? Well, if you're going to conduct the experiment in the lab, yeah, basic solution does make a difference. But if we're just balancing the equation, do we care? It may be in basic solution, but there's no place for the oxygens or hydrogens in this equation. So that's a spectator, right? The hydroxyls are spectators. The waters and the hydroxyls are spectators. So this is all we need, right? We gain 1 electron per silver. And here we lost 2 electrons per copper. So we need to multiply that times 2 to give us 2 electrons. All right, so 2 times this one and 2 times this one. That'll do it. So the question was sum of the coefficients, 6. Okay. There we go. Let's see. Skip a few. Oh, that's the only ones I have marked. Now, if you need practice, if you're not comfortable doing any of the ones that we've looked at today, then go work more problems. And then if you get stuck, go to the worked problems, show you how it's done. You just need to practice. If you're not comfortable, practice. All right. All right, we're a half hour done, half hour early. All right, since there's nobody here and no questions, we're done for the day. And next Thursday, this is Tuesday, next Thursday will be the 30th of April. Yeah, 30 days in April. I'll simply zoom in from my office. And if you have any questions, then you can contact me there via Zoom. All right, we're done for today.